Hello! Today I'm going to be working on my home automation. Specifically, I'm going to be upgrading the server that I use in order to run my Frigate NVR, which is monitoring all the cameras I have around my house and identifying events for example, when there is a human being in view or an animal or anything such like that. The computer I was using is about 5 years old. I built it at the beginning of the pandemic in order to get my wife up and running with a live stream on YouTube so she can continue with her yoga classes. She is a yoga instructor. If by chance you like yoga, go ahead and check out her channel. I'm sure you'll like her classes. Anyway, the computer, like I said, is about 5 years old. It has an RTX 1660 GPU in it, which was sufficient for live streaming, and it's also sufficient for the Frigate use case in order to decode the various video streams coming in and apply the simple YOLO model that Frigate uses in order to identify the various entities within the images. However, Frigate recently updated its software to allow integration with Ollama so that you could submit images from various events to Ollama for further classification and description. Now this 1660 GPU that I have in this computer does allow me to do a little bit there, but not sufficient. I can't run some of the higher parameter models that would get me better results. So today I want to build a new server that allows me to not only run my Frigate installation, but also start running more sophisticated models in Ollama. The computer I'm going with is recently released from Minisforum. It is the MS-A2. This has been fairly well received by various reviewers because of its basically high density in terms of compute power given its small form factor. I was pretty much excited. I actually waited for this computer to come out in order to do this upgrade just because of that. So I am looking forward to getting this up and running. The GPU that I'll be installing in it is this A2000 built by PNY. Now, those of you out there knowing that I want to use the Ollama deployment on this GPU might immediately point out to me that this is not the best GPU possible, that you'd want to get something with more RAM and more cores in order to run the high-end LLM models on top of it. The thing is, I don't need to run the high-end LLM models. I just need to run something that's better than what the RTX 1660 affords me. For this GPU, I did get the 12 gigabyte model so that I can run models of higher levels of parameters. However, I don't need to run the 600 billion parameter models that are out there. I just want to run something that is better than what the RTX 1660 allows me to do. So that's the goal today, is to build out the server and then get my Frigate and Ollama deployment running on top of it. So let's get into it. Okay, here are all the parts for today's build. Of course, there is the central part of it all, which is the MS-A2 mini workstation. I have the PNY NVIDIA A2000 GPU here. The A2000 is able to take up to 3 MTA2 drives, so I have two terabyte drives and one 4 terabyte drive. The 4 terabyte drive will be where Frigate stores historical clips to, and these will just be working drives for whatever I'm running. I am going to install 96 gigabytes of RAM into the server. That is the maximum specified for this machine. I do know others have installed 128 gigabytes into the server. I chose not to try, so I'm just going to go with what Minisforum says is the max. Here's one more thing here that I got this from a company called Nerdware. What it is a conversion kit to convert the A2000 GPU from a dual slot GPU to a single slot GPU so it actually fits in the MS-A2. This is actually a recommended kit for doing what we're about to do. The A2000 is recommended for the MS-A2 as long as you use this conversion kit to actually make it fit. So that's actually going to be the first thing we work on today, which is converting the A2000 GPU from a dual slot one to a single slot one using this kit. So let's clear this stuff away and get working on the GPU. We will start the build with the A2000 GPU. We need to remove the stock cooler that comes with the A2000 and replace it with the slimmer cooler that I ordered from Nerdware. As I look at the RTX A2000, I note that it's already relatively small compared to other GPUs, and especially as compared to the RTX 1660 that is replacing. The first task is to remove the original PCI bracket installed on the A2000. The faceplate screws here are removed with a Torx T8 driver. With a few turns, the screws come off rather easily. Next, I need to remove the 6 screws that hold the GPU's shroud. These are all Torx T6 screws. I focus on the 2 that hold the faceplate in place first so that I can remove it from the GPU. Then the remaining 4 shroud screws are removed. With the shroud screws removed, now it's time to remove the stock heatsink screws. These are also Torx T6 screws, but the back plate here creates quite a bit of back pressure on them. So, as I remove the first heatsink screw, the back plate will pop off with some force. I set the first screw aside and remove the second heatsink screw, and then set the back plate aside. We will use this back plate later, so save it for now. With all the screws removed, the shroud is now removed quite easily. However, to fully remove the shroud, the fan header also needs to be removed. This header was firmly attached, but I was able to remove it with some careful prying. The stock heatsink can now be removed. I found the best way to do this was to gently rotate the heatsink in small movements back and forth. This will loosen the thermal paste that was used when this heatsink was originally attached. Once that is done, the heatsink can be pulled off with some force. Now I need to clean the original thermal paste from the GPU's die. To do this, I use some alcohol and a paper towel. I gently scrub the old paste off the die. This was a little bit challenging as the old thermal paste had hardened. In some places, I had to gently scrape it off. When I was done, I used a microscope to inspect my work. My over 50 eyes are not quite the same as they used to be. Good thing I did, as there was some fiber residue from the paper towel still on the die. I cleaned that off. Next, it's time to attach the new, slimmer heatsink I got from Nerdware. This is a good looking heatsink and quite a hefty block of copper. The first step here is to apply the new thermal pads provided by Nerdware to the memory chips on either side of the die. One thing I'll point out here is I left the clear plastic cover on the thermal pads in place for now to keep the pads clean while I work on the die. Next, I add a dab of high quality thermal paste directly to the die. I also need to connect the new heatsink's fan wiring to the A2000 fan header. Once I do that, I can mate the Nerdware heatsink to the A2000 GPU. Now it's time to reattach the original heatsink backplate. Since the backplate creates back pressure on the screws in order to hold the heatsink tight to the die and the memory chips, you need to be careful when screwing this in. Nerdware does provide new screws to use. I found the best way to handle this challenge is to partially screw in both of the backplate screws, then carefully tighten them down in small steps, alternating between the 2 screws. This will create an even back pressure for the heatsink. With the new heatsink attached, it's time to attach the new faceplate that Nerdware provides. This is attached easily with 2 screws provided by Nerdware. With that, the RTX A2000 GPU has been prepared for use with the MS-A2. Now it's time to build the MS-A2. Looking over the MS-A2, it really is a small form factor. And I really do like all the connectivity you get from it, even though admittedly, I will not be fully using that connectivity in this project. Next, take a look at this power brick. It's almost as large as the MS-A2. One thing that I found out later is that it also gets pretty hot. Now, let's open the MS-A2 and get started with building it out. Opening it up is done pretty easily with the button tab on the back panel. Looking around the internals of the computer reveals that it is pretty well made. First, I will test fit the A2000 GPU. Then it is time to remove the spacer that keeps the empty PCIe slot faceplate in place. It did require some finagling to get it out. Once the spacer is removed, the empty faceplate easily comes out. Now it's time to install the RAM. The RAM slots are underneath this fan here. This fan is removed by removing the 3 screws that are holding it in place. Once those screws are removed, the fan can be slid out of the way. Then, installing the RAM SODIMMs is a pretty standard operation. Once the RAM is installed, the fan can be slid back in place and the 3 removed screws can be screwed back in. Next up is installing the SSDs. To do that, I first need to remove the backside fan in the MS-A2. That also requires the removal of 3 screws. Removing the fan reveals 2 of the 3 M2 slots for the MS-A2. The third M.2 slot was already visible before removing the fan. Minisforum does provide an SSD cooler that can be used with the SSD that gets installed in this slot. So before installing the SSD, I need to attach the cooler. Then the SSD is installed as you would any M.2 device. Next, I install the 2 2TB SSDs into the M.2 slots that are underneath the backside fan. There are no SSD coolers for these slots, so those SSDs simply get inserted and screwed down. Okay, there was a brief interruption in my ability to record. I didn't notice as I was finishing building this out. So you missed a few steps. Admittedly, none of them were significant. It was primarily inserting the GPU into the computer. And so I will demonstrate to you here. It's in. One thing I will note for those of you who are looking, there is a spacer here that I remember I took it out when I first opened up the computer. It is used, I realize now what it's used for. It's used to hold the GPU in place once you push it in. Now that I figured it out, works great. Pushed it in, screwed back in, and everything's held in place. Furthermore, I have the M.2 drives in place with the 4 terabyte one in the NVMe0 position with the heatsink in place. So all looks good. Now, if you're paying close attention when I was putting together the GPU, you probably would have noticed that though I said I was going to take out the clear plastic covering to the heatsink pads that you put on the memory chips of the GPU, I did not do that. I realized that, I realized that later, but the camera gave out, that is my recording gave out, and thus you did not capture me realizing that and going, oh crap, gotta go change it. But proof of evidence is there right here. I did go back in, take this back apart, take those pads out, and make sure that I didn't wreck the actual GPU. So that's been taken care of. So if you're worrying about that, it's good. So let's put this together and get it powered up and get it working. Okay, here we are. I have the MS-A2 hooked up to this monitor, actually through a capture card, so you can actually see what's going on with this monitor better. The power, keyboard, time to turn this sucker on, see what happens. Looks like I got my BIOS screen. So let's check out what we got here. Go to setup, get the basic things. I can see that AMD Ryzen 7945HX, the 96 gigabytes of RAM is recognized. Let's check out boot. I have no boot options right now, primarily because I haven't formatted a disk. The first thing I'm actually going to do is run MemTest. So I have this in a USB stick that I can boot off of. See if this recognizes it. All right. Save and exit. Okay. Let's boot up into the MemTest disk. And now my tests are running. Only thing to do right now is to sit back and let it run out. I am going to pause the recording here. This is going to take a little while. So I will come back when the tests are done. Here we are, 12 hours into the MemTests. I've completed 2 full passes. The Passmark website recommends you do at least 1 pass. If you read online, some people recommend doing 8 passes. At this rate, it would take like 4 days to do 8 passes. I'm going to call this success and say that to the level of confidence that I desire, the memory on this device is good. So we're going to turn it off and then flash Ubuntu onto this computer to get the operating system up and running. Installation was successful. So what I'm going to do at this point is move to my laptop to log into this server so that I can continue the installation process of Frigate Ollama. Since I set this up as a server, I'm going to use it like a server, which means I'm not going to use a graphical login in order to interact with it. So let me go get that set up and I will be back. Okay, here we are. The server has been completely built. You notice I've removed the monitor from it because it's a server. The only thing I really need is this network cable to go into it. And I am going to use my laptop to interact with it from now on. So let me log into the server. You'll notice that I named it Home Lab 1 in my home network. I've already gone on and set up the server to have the kind of shell that I want, which is ZSH, and to add a few things that we will need. Notably, Docker has been installed in the appropriate NVIDIA drivers, including the ability for Docker to pass those NVIDIA GPUs through to a Docker host. That's all been tested. So now what we're going to actually be doing is installing the Frigate and Ollama servers by using Docker and Docker Compose. I did put together a Docker Compose file that I made available as a gist, the link to which will be down in the video description. This has all the instructions that you need in order to deploy this on your own server. This has been optimized for using NVIDIA GPUs. If you're going to do this yourself, make sure you follow the instructions at this URL at the top to make sure that your server has been configured to support GPUs in Docker. The first step is to actually create a set of directories in a destination directory. I've already done that. I've done this at one of my mounts, the data mount and I made a Frigate directory, and within that directory I have a set of folders as described in this instructions right here. Next, you need to create a compose.yaml file, which is basically the contents of this entire compose here. Before I do that, let me walk you through what this compose file actually has. It has 3 services: a Frigate service, a Ollama service, and a Open WebUI service. If you're not familiar with it, Open WebUI is an open source web interface to Ollama that allows you to have a chat style interface, much like you'd see for ChatGPT or Gemini. Each of these services, where needed, they will pass through a GPU, namely the GPU that we have installed. This can work with any NVIDIA GPU as configured. My GPU on this server is the A2000, but you don't have to specify which one. Furthermore, this configuration is set up so that the services know about each other. Namely, Open WebUI needs to know where Ollama is running, and you'll notice the URL here uses the Ollama service name as set up in this Docker Compose file. That detail also needs to be used when you set up your Frigate configuration file. Here in the instructions, notice the YAML block that you need to install into your Frigate configuration file in order to use the Ollama server to use its generative AI services. You'll notice again the URL that you're using to connect to Ollama. It uses the Docker Compose service name in order to do that. Okay, so let's go back and actually create the Compose file as indicated in this step. I will copy the entire Compose configuration that we have here by first going to raw mode, selecting all, copying it, creating a Compose file, vim compose.yaml, and then inserting everything that I just copied. Escape. Okay, now I have my compose file here as necessary. The other thing the instructions say that we have to do is create a place for where the Frigate history files or its recordings will be stored. I have in this configuration file that location be mount that /storage/frigate, which I've already set up on the server. As you recall, when I was setting up the server, it's the 4 terabyte SSD that I installed into the MS-A2. If you're setting this up for yourself, you may have a different location. You'll need to go into the compose file and alter that location. That position in the compose file is right here in the volumes of the Frigate service. I have this particular volume here that indicates to Frigate where to store its history recordings. And this path right here is what you would alter in order to change it to where you're going to store your Frigate history recordings. Alternatively, you could actually set up your computer in much the same manner that I did, and thus you wouldn't have to change anything. The other thing you would need to do is to create a Frigate environments file in the Frigate folder of the directory we created. What this environments file is used for is to pass through any environment variables you need to use in your Frigate configuration, most notably things like camera passwords. You don't have to do this. The way this compose file is set up, you do have to create this file, but it doesn't need to have any content. So if you have no environment variables that you need to pass through to your Frigate configuration, then this file would have no content. I do pass through camera passwords to the Frigate configuration so that in the configuration I don't have any password information. It is actually all contained in this frigate.env file, which I will not be showing you because it actually contains my passwords. Now you do need to create your Frigate configuration file at frigate/config/config.yaml. I have already done that. We can actually quickly inspect mine to see what I have. And you can see that I've already pretty much filled this out for all of my cameras. I have already implemented things like Gen AI support. As you're scrolling through this, you can probably see some of that. The most notable thing I'd like to point out to you is this block right here, which is, as I pointed out earlier, is how Frigate connects to the Ollama server in this overall deployment that we are creating. Notice that we are using the Ollama service name in this URL here. I am going to use this model. Actually, I'm going to use a different model. We will configure that shortly. This is the model that could only run under the RTX 1660 of my prior server. I'm going to be upgrading that to a larger model, which should be able to work on the A2000 of this server. So actually, let's go ahead and do that now. To find the models, you go to this web page, which is just on the Ollama website, which lists all the models that you could possibly download. I'm going to use the Gemma 3 because it is a vision. That means it can actually look at images and understand them. When you look at it, you can select a model by figuring out which one will fit within your GPU's RAM. Now remember, I installed the A2000 with 12 gigabytes of GPU RAM. That means this model here is the largest one that I can actually fit within it. So I am going to copy that one and then edit the model here to be the one that is actually used. Okay, with that saved, we can go back to the instructions here and see what we need to do next. In the compose file, I have a list of many YOLO models that will be used for the identification of entities by Frigate. Now, when you load Frigate for the very first time, it's going to have to build these YOLO models on your server using the GPU that you have on that server. And that can take some time. And so if that list has a number of models that you are not planning on using, you might as well remove them from the set of models that's going to be built. And so here in the compose file under this environment variable of YOLO models, you see I have a bunch of models identified. I am not using most of them, so I am only going to be using the YOLO 7X-320, and so I'm going to get rid of all the others. If you go back to my configuration file, you can see under models that I am using the YOLO 7X-320. So just to confirm that. Now this path in the configuration file for the model is where it's going to be stored within the Docker container for Frigate. This is a standard location within that Docker container. The only thing that you really have to set is the actual model name, as the path before that is standard and should be the same in your configuration file. So with that said, let's go ahead and launch this. To launch it is docker compose up, and I'm going to do a -D to make it detached. So let's go ahead and launch it. It will pull stuff. I've already pulled them to make this faster. Now we can watch what's happening by looking at the logs and doing the tail of 100 and -F to follow. You can see the work that's happening. You can see that it is creating the YOLO 7X-320 model right now. And you can actually hear the server cranking up its fan because it's doing a bunch of work. This will take a few minutes. While this is happening, we can actually get the Ollama model installed that I made reference to. To install Ollama model, we're going to use the running Docker container in order to pull it. So basically this is a command here, and we want to use this model, this Gamma 3 12 billion parameter model, because it will fit within there, and that will pull the model. This also takes a little bit. Okay, the Gamma 3 model has been pulled. Let's check in on the status of Frigate building the YOLO 7X model. To do that, let's look at the logs, but let's focus on Frigate itself. It is still generating the model. One way you can actually determine what's going on is looking at the NVIDIA GPU status, which is NVIDIA-SMI, and it will show you the work that it's doing. And you can see that the GPU itself is currently using 60 watts out of its max of 70 watts. Its temperature is 82C. It has one process going on, which is a Python process. This C means it's a compute process. I don't have any monitor attached, so you won't see any other kind of work that this GPU is doing. And you can watch that. You can actually watch that to see the work that the GPU is doing, and just see how it alters over time, how the power usage goes up and down, the fan setting goes up and down. Okay, but while it's still building that model, we can go ahead and check out Ollama with the chat interface that we also installed, which is the Open WebUI. To do that, you go to your server, which for me is called homelab1.camprath.home.com, and the Open WebUI is at port 3000. The first time you launch it, you're going to have to go through this process of creating an account. Let's make this larger so you can see. Okay, so the account name would just be anything you want. This is running on your own server, so it doesn't have to be super secure unless you expose it to the world. And that will create an admin account. It tells you some information about what's going on with Ollama. Now you see the model that we downloaded was already there. And you get a familiar LLM chat interface here. So let's go ahead and say hi. Okay, let's check back in with the status of building the Frigate YOLO models. I had a configuration error. So let me debug this and I will be right back. Okay, I'm back. I have debugged my problem in the configuration. That is my Frigate configuration. Basically, I copied my Frigate configuration from my original server over to this one, and I forgot to change the MQTT client ID so that it didn't conflict with the client ID that my original server is currently using. So right now I'm running both of this new server and my original server at the same time. So that's what created the problem. We can check that everything is running by looking at Docker PS. Everything is healthy. So now we can actually go look at Frigate. Frigate is at the same URL as the Open WebUI, but with a port of 5000. And you can see I have it running. You can see it around my house right now, which is kind of cool. My doorbell always comes up slow because it's operating over Wi-Fi. Now, the important thing to do is check the LLM configuration. So what would happen is any of these instances, the image should be sent to Ollama in order to get a description. It's kind of slow when it does that. In order to force it to happen, you can click regenerate and it will be going to Ollama to generate a new description. While it's doing that, we can go check the work that Ollama is doing by looking at this command here. Again, using the Docker container to run it. It's just simply the Ollama PS command. And you would see that it is actually running right now the 11 gigabyte model. It is using mostly the GPU and some CPU to get that done. But here's the description. No people present in this image. I beg to differ. Oh, that's right. My prompt says I only care about the front yard driveway porch area or interacting with my rose bushes. But if you actually look at the snapshot, the person is over here on the other side of the road, and my prompt tells the LLM to ignore people on the other side of the road. So it did what I expected. So going back to my gist here containing my Docker Compose file to set this server up, I will also point out a few other things. I do list where you can find the URLs for the various UIs that the service does bring up. The commands you can use, again, this command here, in order to monitor the CPU load, allows you to identify whether your model is being calculated completely within the GPU or it's how much CPU is using. You're going to see in this configuration that the model frequently uses some CPU, but what you want to see is that the model uses mostly the GPU. So look at this command in order to determine whether the model that you're downloaded uses mostly the GPU when it's doing the analysis of the image that Frigate is sending it. In my case, 77% GPU, it works, and it generated a response much faster than my original GPU. Furthermore, I can use a 12 billion parameter model, at least for this particular one. We can try out some other models. If we go back to these model list, we can find others. This Gwen 2.5 VL is another one that allows me to do image analysis. Looks like on this one, I can only run the 7 billion parameter one because that's what would fit within the GPU. If you want to use a model for just the chatbot feature using Open WebUI, then you can consider a few other ones. Gwen is actually a decent one. And in this one, we can actually use the 14 billion parameter one. So let's go ahead and download that and check that out. So it is the Ollama pull command, and I will copy this model name and pull that one also. Now, the problem of having a different model for your Open WebUI and the model that you're using for Frigate is that they won't be able to both fit in the GPU memory at the same time. So you are going to need to be careful about that. And one way to check that is if you go back to the Ollama PS command, it can tell you if it has a model loaded and how long until it's going to be unloaded. It loads models into RAM based on the demand of what is being sent to it. I can show you what happens when both are happening at the same time. So let's go ahead and use the Gwen 3, which is not the one that's loaded into the GPU right now. What will happen while it's working on this is Ollama is going to try to make both work. Looks like you evicted the other one. This one can 100% fit within the GPU, which makes it a great chatbot. Okay, we'll see how it responds to this prompt. Again, we can look at how it's processing. 100% GPU. It is thinking. We can actually see it thinking. It's fun to watch these thoughts here. First, I need to be friendly and engaging since it's a live demo. It's also a... There we go. That's its final thoughts. Hello everyone, welcome to the demo. I'm super excited to show you how to deploy Frigate Ollama and Open WebUI on the Minisforum MS-A2 server. It's a powerful combination for AI-driven home automation and chatbot interactions. Let me know if you have any questions. There you go. With that, I'm going to wrap up this video here. I have a working MS-A2 server in order to run my Frigate and Ollama and Open WebUI deployment. This will upgrade my AI-based monitoring of my security cameras around my house, but it will also provide me with an in-house LLM chatbot that I can use for whatever I needed to use. I hope you liked this video. If you did, please do consider subscribing to my channel. I don't publish often, but when I do, I publish on various technical topics like this one. Do like this video if you did enjoy it, if you found it useful. Leave some comments below if you have any questions or any suggestions for improving this deployment. I will leave links to the various sources of information that I talked about in this video down below in the description. Again, if you found this video useful, please do like it. And until next time, goodbye.